So I hope everyone had a good Thanksgiving. We caught up on that a little bit. And let me just dive into the 101 shell. We've got 2 weeks of class left, so we're going to cover Chapter 13 and Chapter 14. I think there's one more problem set and one more summary. We'll dive into that a little bit, but let me first just take a look at the syllabus. I asked Peter to go ahead and finish up grading the exams because I think there are a few people who said, hey, I haven't seen my exams graded yet, and so hopefully he's done that for you. And I might be a little bit behind grading the summaries. I've still had a lot of people asking questions. I had a lot of people saying, hey, I'm going to knock out summary 3 over Thanksgiving break, so hopefully those are mostly done. I have not even started looking at the summary 4 yet. So like I said, the last 3 things to wrap up are summary 5, exam 6, and problem set 3. Those are the last 3 things that are due.
Are we going to take, like, there's the final exam online, are we going to take that in class for,
Yeah, so the question is, what's up with the final? And I'll just make a note of that, show it to you graphically. So let's just say here are your exam grades: 3, 4, 5, 6. There's 6 exams, and let's just say you got, like, a 90, an 80, 85. Maybe you tank this one. You got a 50. You ace that one, then you got a 95. So let's say you're looking at that as your exam grades. You're like, oh man, this is terrible. If you take the final and say get an 80, that one goes away and that becomes a replacement grade.
Oh, okay. Cool.
If you take the final and if you take the final and get a 0, the 50 stays.
Like, even if you got like a 51, if you replace that.
If you got a 51, we'll replace it. Now, I will tell you about the final. It's relatively challenging, and I'll give you an example of the type of problem that you might expect to see on the final. I was just doing this with my kids driving to Yellowstone the other day. But let's just say, here's the question. So you're driving a car, and there's no gas tank. But instead there's just a little straw of fuel alongside the road that you're sipping from or drinking from. And so the question is, what's the diameter of that straw? So what you would do, you think, oh gosh, if I get 20 miles per gallon, that basically means that I've got a 20-mile strip of road. Basically means you spill a gallon of fuel over that 20 miles. So you've instead of having like a gallon that's shaped like a gas can or a milk jug or whatever, you've got a gallon of gasoline that's a cylinder that's 20 miles long. So how would you do that? Well, you'd say volume equals pi r squared L. L equals 20 miles. Volume equals 1 gallon. Now you do your units conversion, and now you can find the radius. It's stuff like that. And as it turns out, the answer to that problem, it's bizarrely small. Like, oh, it's a centimeter. Oh, it's about an inch. It's 100 microns. So it's 0.1 millimeters. And so what I would do.
If we got the answer 0.1 millimeters and didn't put it in microns, would you accept that? Or
no, because here's what I would ask it for. I would ask you for the answer in meters. I would say, how many meters is that? And well, if it was 1 millimeter, it would be 10 to the minus third meters, because there's 1,000 millimeters in a meter, but it's 0.1 millimeters, so your answer is actually -4. So the answer to that
Makes no sense.
makes no sense?
Well, -4.
Oh, it's
Like, how would you have a -4 diameter?
oh, because the diameter equals 10 to the -4 meters.
Oh, okay.
So all of your answers are given in powers of 10.
Okay.
That's what the final looks like. It's just kind of quick and dirty problems like that. It's the same thing when I gave you that problem, I said how fast, if all of the Earth's coal consumption was just on a single train, how fast is that train going? And if I asked it for you in miles per hour, and we did this problem in class, it's 180 miles per hour. And if I asked that in powers of 10, well, let's see, if it were 1.8, that would equal 10 to the 0 power. If it were 18, that would equal 10 to the first power, approximately. If it were 180, that would equal 10 squared. Yeah. If it were 1800, that would equal 3. So your answer would be 2. And on the final, this would give you 100% credit. This would be 90%, 90%. This is how I just scale it. So you can even, like, the point is, you can guess and be pretty close.
Yeah. I mean, it's already, it shows the whole process.
Exactly. So that's kind of what the final looks like. Like the problems seem like really hard at first, but on the other hand, if you just say, gosh, how big is that thing? Well, if I guessed a centimeter, that would be -2, and you still get 80%. Yeah. So the answers are all just integers. Not all of them are like that, but and these are actually called Fermi problems. So there's a physicist, Los Alamos physicist, Enrico Fermi, who the famous analogy was they were standing something like 20 miles away from one of these first atomic blasts. There was instruments, of course, closer, but he wanted to estimate the power of the blast just by dropping a leaf and seeing how fast the wind was blowing it 20 miles away.
Wow.
Yeah. So anyway, that's what the finals look like. So just to recap,
And is that in class here, or is it?
you can do it in class or online.
Would that be like on the 12th then? Is there like-
I'm going to do, so the final will be available, sorry, my phone's ringing. The final will be available the 14th through the 20th.
Finals from 14 to the 20th.
Yeah.
Cool.
And if you want to take it in class, I think there is a final schedule, and I'll look that up during the break. So you can come take it in class.
Well, I think,
And it's kind of nice. It's kind of nice to come sit down and take it in class.
yeah.
And I'll just, I'll print up a hard copy of the problems and come in and take it for sure. But again, it can only help your grade.
Yeah.
Yeah. Yeah. Does that answer your
Yeah.
question? Good. Super. All right. I'll just pause that really quick.